Hello, I'm Nikita Patkar from the Global Environmental Health class of Fall 22, and I'll be discussing perspectives on recycling of used lead acid batteries. Used lead acid batteries are the first rechargeable batteries invented. They make up for 86% of total global consumption of lead and have a global recycling rate of almost 99%. They're used in automobiles, electronics, industry equipment, backup power supplies in cell phone towers, and emergency power systems like hospitals. Akbok is the world's largest e-waste dump site in Accra. Hundreds of workers remove lead from the lead acid batteries of automobiles or computers dumped there. Lead acid battery recycling as the world's most deadly industrial process in terms of disability adjusted life years lost, resulting in 2 million to 4,800,000 estimated years of individual human life lost globally. It is observed that if 4 kg of waste batteries are randomly embedded or abandoned, 2 square meters of land will be contaminated. There are environmental and health problems due to improper used lead acid battery recycling. The environmental effects are that the stripped away leftovers from the batteries are left to be dumped in unlined pits or waterways. The black smoke that hovers over the site is usually constantly present after copper cables are lit to burn off their plastic coatings. There are several health problems like convulsions, seizures, developmental delays, lower IQ, behavioral problems, which are prevalent especially in children, and abdominal complaints like pain, constipation, diarrhea, nausea, vomiting. Females also suffer from premature births, stillbirths, or spontaneous abortions. There are cardiovascular related deaths, impaired renal functions, and respiratory problems caused due to burning fumes. Simply banning the process of ULAB recycling isn't sustainable. We will take a look at the different professionals suggesting the interventions to limit the harm. Professional number 1 is Siddharth Pimprikar, a senior engineer at Qualcomm San Diego. Professional number 2 is Nilima Patkar, a teacher at Shabda Shilpa Hindi classes for high school students in Mumbai. Professional number 3 is Kamakshi Dharadhar Patkar, a senior HR business partner, engagement and CSR at DCB Bank, Mumbai. Siddharth Pimprikar states that one of the interventions that can be implied for this is that governments need to provide safety gear like masks and suits and protective equipments to avoid direct contact with lead in the recycling process. Another one is that instead of melting lead and burning the batteries in an open furnace, it should be moved to a closed area so that any byproduct formed in the process can be filtered out and their disposal outside can be better controlled. Third, subsidize recycling cost to battery manufacturing plants so that individuals can collect and sell it to the already existing industrial setups, preventing them from being actively involved in handling the process. Lastly, you can switch to lithium-ion batteries which have a longer life, better discharge rates, limited maintenance needed, so much lesser production and recycling will be needed. Nilima Patkar, the teacher, suggests that you need to provide formal training to people included in recycling lead acid batteries to ensure they know how to safely execute the process as well as take these protective equipment seriously. We need to educate them about the consequences to their health due to exposure to lead and or lead dust. Spread awareness of the situation through media and literature. Help find and create alternative modes of income for these people. Build bathing and changing rooms at on-site locations to clean up after work and shift the recycling areas away from the residential neighborhoods. Kamakshi Dharadhar Patkar suggests formulating government policies to implement environmental, health, and safety standards for recycling and monitoring the process. Banks to give loans to projects like Pure Earth in Akbok Ploshi e-waste recycling centers which automate the process and make it safer. Privatization and recruitment of workers in the new recycling plant. encourage CSR funding for research on safer lead recycling alternatives, government to ascertain strict regulation of the disposal of the end products. Assessment of these interventions are the first one suggesting building industrial recycling plants complying with safety standards and finding alternatives to lead acid batteries. Secondly, educating individuals about the harmful effects of lead and proper usage of protective gear. Lastly, government policies to standardize lead recycling and create funding for safer methods. The possible interventions are briefly summarized under three main categories: education, government, and alternatives. Education, training for safe handling of the batteries and consequence of exposure. Government, with implementation and accountability of maintaining safety standards and providing safety gear to the workers. Alternatives require funding recycling plants that recruit these workers and creating alternative sources of employment for these people. Lessons learned through this interprofessional assignment is that each of the three professionals had a different approach to the interventions depending upon their profession. Since banning lead acid batteries recycling is not fiscally feasible, these interventions will help regulate the process more closely. It would take the combined effort of government, policymakers, financial system, and the common public to limit the harm caused by this. Lower and middle income countries are usually less strict about monitoring handling materials as compared to the first world countries. So there should be an active government role backed by education of the people involved in it to bring about a sustainable long-term change to the informal recycling of lead acid batteries. The references used for this presentation are. Thank you.